Our second shuffle is also a judicious push-off pairs shuffle, but this time we will stack the final right pile on top of the left pile. So let's go ahead and illustrate that. So as always, we begin with our ordered packet, 1 through 8, and we'll perform our shuffle. So this is a push-off, so you just push off the cards without changing the order of the cards within that pair. And push off the next two without changing their order, and the last two. Now the stacking is the same as the previous one. It's a leapfrog stacking. So we're going to stack the first pile, so this is pile 1, 2, 3, 4. The first pile on top of the third, the second pile on top of the fourth, and then finally the right hand pile gets stacked on top of the left. So what is the new ordering of this packet after that shuffle has been completed? Well, let's take a peek. The new ordering is 3, 4, 7, 8, 1, 2, 5, 6. So expressed in Cauchy's two-line notation, we obtain the following. The top row, as always, is 1 through 8, and then we simply list the new ordering of the cards. 3, 4, 7, 8, 1, 2, 5, 6. Converting this to cycle notation, we obtain the following. Note that 1 goes to 3, so we have an arrow from 1 to 3. 3 goes to 7, so there's an arrow from 3 to 7. 7 goes to 5, so there's an arrow from 7 to 5. And then 5 returns back to 1, so that completes that cycle. And this cycle is of length 4. This is called a 4 cycle. Continuing on, we see that 2 goes to 4, so we have an arrow from 2 to 4. 4 goes to 8, an arrow from 4 to 8. 8 goes to 6, an arrow from 8 to 6. And then 6 returns back to 2, completing a second 4 cycle. Color coding these position values, we obtain the following. Remember, position values 1, 4, 6, 7 are color-coded black, and position values 2, 3, 5, 8 are color-coded red. Using that convention, we get the following. Black 1 goes to red 3, which goes to black 7, which goes to red 5, which cycles around to black 1. In our second 4 cycle, we get red 2 goes to black 4, which goes to black 6, which cycles back to red. So here, each value gets sent to a value of the opposite color. Consequently, inversion has occurred. This simply means that the cards that originally began in positions 1, 4, 6, 7 have moved to positions 2, 3, 5, 8 after the shuffle, and vice versa. Cards that originally began in positions 2, 3, 5, 8 get moved somewhere to positions 1, 4, 6, 7. So there's been kind of a wholesale exchange of the cards in those 8 positions. And consequently, we would represent this situation as follows. A goes to A complement, and A complement goes to A. Since inversion occurs, we should be able to detect that applying this shuffle to the Bessey sequence 1, 0, 0, 1, 0, 1, 1, 0. And so what should happen is we should obtain the inversion of this sequence, which will be 0, 1, 1, 0, 1, 0, 0, 1. So the zeros and ones simply trade places. Okay, so let's go ahead and just perform this shuffle again. So we're pushing off pairs. So you just push off 2, push off 2, push off 2, and then push off 2. The stacking is this leapfrog stacking. So this pile 1 leaps over pile 2 and lands on top of pile 3. Pile 2 leaps over what was pile 3 and lands on top of pile 4. And now here we're stacking the right pile on top of the left. So what should be the case now is the sequence that we started with should be, quote, inverted. In particular, that means we should now have 0, 1, 1, 0, 1, 0, 0, 1, which we do. Now, it is true that the zeros and ones are moving places. In fact, all of them have moved to new locations. And that's evident by our representation of the permutation. We have no fixed points this time. So every single card has moved to a new location. And the shuffle diagram for shuffle 30 is the following. So we see that 1 goes to 3, which goes to 7, which goes to 5, which wraps around and goes to 1. So if we begin at 1, there'll be an arrow from 1 to 3, which there is, an arrow from 3 over here to 7, and then from 7 down to 5, and from 5 back up to 1. So that completes that 4 cycle. We also say that the values 1, 3, 5, 7 in that cycle constitute an orbit, or that they are members of the same orbit. Similarly, for this 4 cycle, 2 goes to 4, which goes to 8, which goes to 6, which goes back to 2. So if we begin at 2, there should be an arrow from 2 down to 4, which there is. There should be an arrow from 4 up to 6, which there is. And there should be an arrow from 4 to 8, which there is. From there, an arrow from 8 to 6, and then an arrow from 6 back to 2, completing that 4 cycle. So those 4 values, 2, 4, 6, 8, also constitute a second orbit, since they just move around among themselves each time this shuffle is performed. And as we'll see in just a moment, shuffle 30 is the inverse of shuffle 32. Okay, and we'll demonstrate that in just a moment.